At this point, I want you to get familiar with a very important concept associated with scalar fields, namely level sets. Let us have a look at the following scalar field. Let's take a look at G once more. G is a scalar field defined in three-dimensional space, mapping into the real numbers, and it just takes a vector. That should be it just takes a vector, and what it does is it adds up the squares of the coordinates. So we take a vector x, and we get x1 square, x2 square plus x3 square. The level set for the value 1 is defined as follows. The level set of G for the value 1 is the following set of vectors. We take the set x, all the vectors in R to the 3, for which the function g equals 1. Meaning g of x equals 1. Similarly, you could also define the level sets for the values 2, 3, pi, whatever. And very explicitly, just using the formula for the scalar field G, that's really just a set of all vectors for which the squares of the coordinates add up to 1. That formula might ring a bell, because it actually describes a very familiar geometric object, something you've certainly seen before. If you take a look at this formula, you realize this describes the unit sphere in three-dimensional space. Let's try to visualize that. So we got our 3 coordinate axes in three-dimensional space. We got the x1 axis, we got the x2 axis, and we got the x3 axis. And roughly speaking, if you try to visualize this, it will look as follows. This is just an illustration, an attempt at an illustration of the three-dimensional sphere, which is described by this level set.